Hello students, welcome to the lecture on managing information flow in supply chain, and after this lecture we will be able to learn the following objectives. Describe demand forecasting and how to manage demand in the manufacturing industry. Explain the managing demand in the service industry. Explain the role of forecasting in supply chain. Discuss the quantitative methods of forecasting. Understand multiple linear regression method. Describe the risk management in forecasting. Let's start with the concept of managing information flow in supply chain. Nowadays, companies are in the race for improving their organizational competitiveness in order to compete in the 21st century global market. This market is electronically connected and dynamic in nature. Therefore, companies are trying to improve their agility level with the objective of being able and responsive to meet the changing market requirements. In an effort to achieve this, many companies have decentralized their value-adding activities by outsourcing and developing virtual enterprise (VE). Supply chain management (SCM) is an approach that has evolved out of the integration of these considerations. SCM is defined as integration of key business processes from end user to original suppliers that provides products, services and information, and hence adds value for customers and other stakeholders. Let us now discuss the demand forecasting. A root problem in supply chain management is the unavoidable uncertainty in predicting future demand. This condition manifests itself in the unreliable sales forecasts that form the heart of many inventory management and planning systems. Contributing to this nebulous nature of predicting the future is the distortion of past facts as the usual communication platforms, which include telephone, mail, fax, some EDI processing and a bit of e-commerce, are often rife with mistakes, errors and manual overrides. What typically goes into the upstream side of the chain is quite different from what is needed at the downstream side. In the early levels of the supply chain evolution, this complication leads to allowances being made for forecast error, additional buffers to inventories to cover contingencies, change schedules and heroic efforts to respond to special customer condition. Processing is oriented around how to replenish those items using optimized condition. In the advanced levels, consumption triggers this replenishment often through an active online network that transfers cash register data to planning system, a key element in the true pull system. Higher turns in the most profitable items are experienced because of high forecast accuracy and a low bias in the forecast, which helps the firm avoid having too much or too little inventory to meet actual demand. Supply capability is reviewed in the advanced levels with respect to the core competencies of the firm and its values chain partners and decisions made on which partner should perform which process steps. In the most advanced levels, flexible system of responsive are created. There is much lower variability in the network as all parties are working together through an online extranet to review instantly what is occurring and where changes must be made. Forecasting is the Achilles heel. Throughout this progression, supply chain efficiency is inexorably linked with a better understanding of exactly what is being demanded of the system. All of the process steps mentioned is affected by what is needed, when and where. And forecast error often becomes the scapegoat of a lack of an efficient response. Since forecasting is an inexact science, forecasts will always be inaccurate. The most common mistake interfering with the development and deployment of a successful forecasting system include lack of an ongoing and rigorous progress of forecast error measurement. Advanced firms have automated ongoing processes that measure forecast accuracy using meaningful and accepted definition. Lack of organizational acceptance of the need for accurate forecasts. Lack of clear organizational ownership of the forecasts that are generated. Without an obvious responsibility, everyone can run for cover and use weak forecasting as an excuse for all the poor processing and extra inventories. lack of clear rewards and incentives for forecast accuracy. Typing forecasts to sales quotas, for example, can produce some very bad results as salespeople lowball forecasts to ensure they beat their sales target. Failure to understand the underlying patterns and the reason for variances. Failure to involve senior executives in the forecasting process. Better forecasting starts with asking the right people the right question. The particular problems occur not just around determining the direction of demand, but with the magnitude of the demand in a particular time frame. Forecasters can generally react well directionally. They tend to fail in knowing how much is needed for an adequate response, typically predicting higher sales than actual, and they tend to be slow in stemming the tide of extra inventory. The effort expands with a realization that forecasting is a key component affecting information strategy across a firm and its network partners. We see that information flows between many components of a business, all of which derive data from the forecasting process. Demand forecasting is directly linked with supply chain management and the enterprise data warehouse. It also links with consumer relationship marketing, trade sales and marketing, retail operation and the information infrastructure, and is used for virtually all planning steps and financial analysis. The idea is to seek an integrated system, so the flow chart must include how withdrawals are made from what is in current inventory, including work in process, material at co-packers or sub-assembly operation, product in transit, and materials and product on hand with suppliers and customers. In short, all of the linkages need to be identified so we can ask where it is working and where it is broken. With increased forecast accuracy and less forecast bias as the objectives, the firm sets about considering the alternatives to accepting poor incoming information, including working closer with key customers to determine actual needs, performing deeper supply chain analysis, applying demand smoothing, and collaborating with those network partners having useful information in their databases. The second key is to make the effort as active as possible. That means a partner should be less inclined to accept the customer demand pattern as sacrosanct. Demand smoothing requires the partners to look for ways to minimize the variability or the volatility of the accepted forecast. It requires them to separate the inherent demand variability caused by natural consumption factors from the artificial variability introduced by supply chain practices. Now moving on to the next topic, we will study the managing demand in the manufacturing industry. Increased global competition has severely impacted American manufacturing in that customers have developed a heightened perception or acceptation of what makes up a satisfactory quality, price and service. The same trend is appearing in many service industries as international competition is becoming more evident in airline travel, tourism, banking and real estate. As competition increases and customer expectations rise, the need to manage customer demand becomes more important. The future of many manufacturers may depend on how well they integrate their product with their service package to provide a complete goods service package that can be customized in both time and content for individual customers. Manufacturing businesses, whether discrete or process, may be confronted with some of the following supply chain challenges. The need to balance manufacturing efficiency with inventory efficiency. Finding an optimal balance between the 4 C's, customer service levels and capacity. Optimizing the balance between demand requirements and manufacturing requirements. The link between operation and financial. The link between planning and results. Stock levels, cost and lead times. Integrating demand planning, distributing planning and manufacturing planning. Optimizing production policies. Let's now discuss managing demand in the service industry. The literature on capacity management focuses on goods and manufacturing, and many writers assume that services are merely goods with a few odd characteristics. Unfortunately, these researchers never fully explored the implication of these strange traits. Services are direct, they cannot be inventoried. The perishability of services leaves the manager without an important buffer that is available to manufacturing managers. There is a high degree of producer-consumer interaction in the production of service, which is a mixed blessing. On the one hand, consumers are a source of productive capacity, but on the other, the consumer's role creates uncertainty for managers about the process time, the product's quality, and the facility's accommodation of the consumer needs. Because the service cannot be transported, the consumer must be brought to the service delivery system or the system to the consumer. Because of the intangible nature of a service output, establishing and measuring capacity levels for a service operation are often highly subjective and qualitative talks. Increasing the wrong kind of capacity. In studying the battle statistic in the war for market share among airlines, competitors observed that an air carrier in a military positioned on a particular route would often get a smaller proportion of the total passenger flown on the route than the share of sheets. Conversely, the dominant airline would carry a disproportionately larger share of the total passenger flown. Patterns of demand. Very little work has directly examined the links between consumer demand and the pattern of employment. We propose to investigate patterns of consumer demand and how it interacts with labor market outcomes. In particular, we will try to ascertain the extent to which goods and services are consumed by different income classes and estimate different elasticity of demand across these goods and income classes. We will then try and relate observed labor market outcomes to these estimated price elasticity of demand for different products. A company's supply chain encompasses all of the facilities, function, and activities involved in producing a product or service from suppliers and their suppliers to customer and their customer. Supply chain function include purchasing, inventory, production, scheduling, facility, location, transportation, and distribution. All these functions are affected in the short run by product demand and in the long run by new products and processes, technology advances, and changing markets. Long-run forecasts of technology advances, new products, and changing markets are especially critical for the strategic design of a company's supply chain in the future. In today's global market, if companies cannot effectively forecast what products will be demanded in the future and the products their competitors are likely to introduce, they will be unable to develop the production and service system in time to compete. Levi-Strauss employs a supply chain with regional cluster of suppliers, manufacturers, and distribution centers linked together, thereby reducing inventory and improving customer service. The goal of this supply chain design is to have inventory close to customers so that products can be delivered within 72 hours. Levi-Strauss arranges weekly store orders based on actual sales patterns received electronically from source through EDI, electronic data interchange. It uses weekly forecasts of demand that extend 60 weeks into the future. Strategic planning. There can be no strategic planning without forecasting. The ultimate objective of strategic planning is to determine what the company should be in the future, what markets to compete in, with what products to be successful and grow. To answer these questions, company needs to know what new products its customers will want, how much of these product customer will want, and the level of quality and other features that will be expected in these products. Insight. Supply Chain Management (SCM) software can help facilitate the process of forecasting and measuring the supply chain, synchronizes the supply and demand cycle through the use of real-time information. As a result, inventory is less likely to sit unused. A statistical technique for making projections about the future which uses numerical facts and prior experience to predict upcoming events. The two main types of quantitative forecasting used by business analysts are the explanatory method that attempts to correlate two or more variables and the time series method that uses past trends to make forecasts. These methods rely on experts who try to quantify the level of demand from the available qualitative data. The two most widely followed methods are degree of execution opinion method Opinions of a group of experts is called for, and these are then combined to arrive at the estimated demand. Delphi method. In this method, a group of experts are sent questionnaires through mail. The responses received are summarized without disclosing the identities. Further mails are sent for clarification in case of extreme views. The process is repeated till the group reaches to a reasonable agreement. Time series. Forecasting is a method or a technique for estimating future aspects of a business or the operation. It is a method for translating past data or experience onto estimates of the future. It is a tool which helps management in its attempts to cope with the uncertainty of the future. Forecasts are important for short-term and long-term decisions. Businesses may use forecasts in several areas: technological forecasts, economic forecasts, demand forecasts. Moving average methods. Moving average techniques forecast demand by calculating an average of actual demand from a specified number of prior periods. One of the easiest, most common time series forecasting techniques is that of the moving average. Limitation of moving average methods. Moving averages are considered as smoothing forecast technique because we are taking an average over time. We are softening or smoothing out the effects of irregular occurrences within the data. Weighted moving averages. The moving average may be the most universal of all technical analysis indicators. While it is tempting to dismiss the moving average as antiquated, its staying power is testament to its utility. Initially, the only type of moving average was a simple arithmetic average, easy to understand and quick to calculate. Understanding and comparing the calculations. A moving average is calculated by average price values from a specific number of bars. Specifically, there are two parameters input for a moving average formula: price, a single price value from each bar to be used in calculating the average. Traditionally, the price value used is the close price of each bar. Length, the specified number of bars counting backwards from the current or most recent bar from which to draw the data points. Simple moving average. A simple moving average, SMA, also known as an arithmetic average, is a common average of the price values in the data series. Each price in the data series is equally weighted, that is, there are no weighting factors applied to any of the data points. Exponential smoothing. This is a very popular scheme to produce a smoother time series, whereas in a single moving averages, the past observations are weighted equally. Exponential smoothing assigns exponentially decreasing weights as the observations get older. Price forecasting is an integral part of economic decision making. Forecasts may be used in numerous ways. Specifically, individuals may use forecasts to try to earn income from speculative activities, to determine optimal government policies, or to make business decisions. Like any other goods, gold's price depends on supply and demand. But unlike palm oil, say, where most of the current supply comes from this year's crop, gold is storable and the supply is accumulated over centuries. For example, in year 1998, the total world supply of gold is 1,25,000 metric tons and the annual range is around 2,400 tons. This means that in contrast to palm oil, corn or soybeans, this year's production has little influence on prices. Since gold behaves less like a commodity than long-lived assets such as stocks or bonds, gold prices are forward-looking and today's price depends heavily on future supply and demand. Thus, the forecast of gold price depends on the market psychological perception of the value of gold, which in turn depends on a myriad of interrelated variables, including inflation rates, currency fluctuation, and political turmoil. In this study, we first present the forecasting model for predicting future gold price using multiple linear regression method. Then, we discuss the performance of the selected model, and finally the comparison between the final model and a benchmark model is presented. Uncertainty fuels the need for risk management, although risk, if adequately measured, may be less than uncertainty if measurable. Forecasting may be viewed as a bridge between uncertainty and risk if a forecast peels away some degrees of uncertainty, but on the other hand, for example, may increase the risk of inventory. Therefore, forecasting continues to present significant challenges. Presented findings from electronics industry, where original equipment manufacturers OEM could not predict demand beyond a 4-week horizon. Now, in the end, let us summarize what we have learned in this lecture. SEM is an increasingly applied operation paradigm for enhancing overall organizational competitiveness. Forecaster can generally react well directionally. They tend to fail in knowing how much is needed for an adequate response, typically predicting higher sales than actual, and they tend to be slow in stemming the tide of extra inventory. This is especially hurtful in today's competitive global business environment where customer service and on-time delivery are critical factors. The real gross domestic product GDP provides good example of a time series that displays cyclical behavior. Random variation in the time series are caused by short-term, unanticipated and non-recurring factors that affect the time series.